Right now, last week also we discussed about the object-oriented concepts. Under that, we have discussed method overloading and method overriding, and we did some practicals as well. Now, we're going to talk about the double OP concepts or object-oriented concepts. If you can remember at the very first day, we discussed that in Java, the objects talk to each other, objects communicate with each other, likewise. Right, then we'll talk about this. So what are the concepts behind these objects and then how these are working. Right, whenever you talk about object-oriented concepts, you have to know that what is an abstraction, what is an encapsulation, and what is polymorphism, and what is inheritance. Right, now the abstraction. The abstraction, or you can name it as abstract. Yes, the abstraction means data hiding. That is the process that the programmer hides all the information about the objects in order to reduce the complexity and also to increase the efficiency. That means, for an example, the way object should behave is defined inside a class. And then now we have already talked about the access modifiers. Then we know already about access modifiers. Then based on the access modifiers, you have different access levels, right? Then sometimes you will not be able to see what are the variables or what are the members of that particular class. Likewise, then if it is a public access we have, then everything will be visible to others. If it is a private, only within the class. If it is default access, only within the package. Likewise, if you can, we have discussed in the previous week. Right. Therefore, the abstraction is hiding all but the relevant data about an object in order to reduce the complexity and increase the efficiency. Right. Then class is a if you can remember, we said class is a blueprint, class is a template. Likewise, yes, class is a general abstract representation of an object. The class specifies, class declares what are the fields, what are the methods that each object has. And inside the class, what we have is not visible if we have put proper access modifiers. Therefore, a class is a general abstract representation of an object. Therefore, object remains as a representation of the original with unwanted details sometimes. For an example, let's say if there is a class called student, and the student has a field called marks, and if it is a private field, then no one will be able to see what is that field. But that object has the marks field, but you will not be able to, outsiders will not be able to see it. Likewise, then a class, the way you declare the class is the abstract representation of an object. Class specify the fields and methods that object has. Right, then for an example, if you consider uh, a class called car, then car class describe the features or the information we want to store about car objects. That means if the car has a model, a color, or what are the behaviors like start, stop, brake, likewise. And then we can declare all the methods, all the variables to describe the information that each object should store, and also to define the behavior that each object can behave. Right now, the methods, that means start, stop, likewise. Then the class car is the abstract model for the concept of a car. And then you can create many objects from the class car. Right. That is what you call as data abstraction or data hiding. Right. Then encapsulation. Then the second one we call as encapsulation. What is encapsulation? Encapsulation is the mechanism, right? Or that binds together the methods and data it manipulates and keep both safe from outside interference and misuse. Right. For an example, encapsulation, you can say, right, in day-to-day life also you will see capsules, right? Medical capsules. But you don't know what's inside there. But you know that for sure that is medicine is there, right? Medicine is there. But you can't see what's inside the capsule. But you know there are medicine. Right. Then encapsulation is also the same. Right now, let me show you how you achieve the encapsulation in a project, in a Java project. Right. Okay, let's show these classes what we have here. Right. Now let's create a class called student. Right. Right now, the student class, let's say student class has a string variable. Now, this is the abstract model we are dealing with. Now, we gonna declare what are the information we need to know. String, integer, ID, and student name, student ID, and then let's say marks. I have marks, right? Average mark, average mark. Right. Now then I have three variables. Right. Now here I have method called print. Okay, let's say um set. Okay, I'm gonna set the marks. Void set marks, and I'm gonna set a mark. Right. Now let's say I have only these three methods. Right. This is the class. Right. Then I'm gonna create another class called student. Right. I'm gonna create another class called test. Right, now here, let's define the constructor as well. It's easier. We'll have the constructor, right? Right. Then now I have the student class created. Student class has the constructor, and I have a method called set marks and printing. Right. Now, if I want to print, now if I want to print the student class, all right, if I want to access the student class name, right now I can get student class name using s dot name. I can access the name. And then I can, if I want, I can change the name as well. Then I can say that name is equal, right, and and right. I can change the name, right? Then I can change the ID as a now student ID also I could change, right? I can access the ID as well. Right now, if I want, I can change the name as well, and then I can change now. Okay, I can like name change. Right now, if I want to get the average mark, if I try to access the average mark now, you can see I can access the average mark, and here average mark is visible because it's a default. But now here I'm gonna do okay. Right now, let me do some trick. Average mark change to average mark. Now, if I run this, and then here I'm gonna call this as dot print info as well. Right. Right. Then right now I'm gonna change name Jane Doe, the name change to N0, ID 9001. Then here I'm gonna have the ID value as well. Right. And then in node right. Then if you run this, now it will display what are the initial values, and along with it, it will display the new values as well. Name, Jendo name change to answer. ID 9001, ID change to 111. Average mark 0, then average mark change to 55.5. Then the new values will be displayed using the print info method. Right now, this is what you call as now. This is where we declare how the objects of the student class should behave, right? We have decided that our name, ID and average mark are the variables we need to have for the student. And every student should have the constructor. Anyway, it will be default constructor would be there if you have not declared. And then there should be a method called set marks, and there should be a method called print info. Print info method is to print these details in this format. Right. Now, if I have changed, let's say the marks variable as a private now. Now I'm going to declare that I don't want other outsiders. I don't want outsiders to access the. I don't want outsiders to access the average mark variable. Right now, when I make it as private, now you will see here I will not be able to print the average mark like this because no way of accessing the average mark and no way of setting the average mark is like this because outsiders are prohibited of accessing the private members, right? Then because if it is a private, you have class only access. Therefore, now outsiders are the test is an outside class. Even though test class has access to the student class, test class could create an instance of a student class. Test class has no access to the average mark variable because it is private key. Therefore, now you can't. But if you really want to do this, if you really want to let this happen, now that's why if you want to allow to change the marks, that's why here you have declared a method called set marks. Then you could access s dot set marks method and you can pass the value. You can pass the value. But you will not be able to read the marks variable because there is no method declared to read the marks. If you want, then only you have to declare because you don't want outsiders to read the marks variable, average mark value separately. You don't want outsiders to access the variable average mark. That's why you have made it as private. Now, this is also cannot access. But only from the print info, you can display. Because print info can access the average mark value. Why? Within the class, you could access. Therefore, now if you run this, now the 55.5 get updated because using the set marks method you are updating. But previously you could have updated object name dot and the field name. Using the object name dot and the field name, you could have done it. Right now you can see answer error ID 1111 average mark is 55.5 because you can't access directly, but you have decided to let the access through a method. Therefore, at the time you declare the class, you have declared a method called set marks. Now that is because of this you could access. Now let's say now if you don't want any outsider, if you don't want any outsider to access any of these instance variables through the dot operator, then what you have to do? You could declare private fields. You could declare the private fields. Now, no one would be able to access using the dot operator. See, no one would be able to access using the dot operator. And if you want to allow only to set the, let's say, the mark or the name only, if you want only to change the name only, if you want to only to allow to change the name only, then you can have this name equals name. Only to change the name. You want to allow only to change the name and other, let's say only to read the all the variables. So you are allowing them to read the values of these fields, but not to set, only to set the name. Then you can have string get name return name. Int get id And, right now you have declared methods. Right now, normally, you may declare public methods. Right now, then you are providing access to anyone, regardless the package. No, when you are declaring the getters and setters. Therefore, even now here, if you declare without the public means default access, right? Now let's make it as public. Now even this would make within the package level, but anyway, as a habit, we'll make it as public. Right now, this is float. Right now, here we have declared. Now, once you create the student object, now if you want to set the name, you could set the name by s dot set name and by passing the name. S dot set name by passing the name, and nothing else you could change. Right now, nothing else you could change. And if you want to access the name, then you have to access through s dot get name method. And if you want to access the ID value, then you can't access like this. You have to access through get ID. And no way to set the marks. Then if you want to get the marks, then you have to access through get marks method, right? Then then only you will be able to do that. Right now here only these methods are there now. Therefore, if you really want to set the marks, you can't, because you have not given provision to update the marks or whatever the value of the object, only the name only, and then others are to read only. Now this is how you declare. Now declaring these you call as declaring getters and setters. Therefore, quickly try out this. I'll give you very few minutes, like 1 minute or 2 minutes only. Therefore, quickly try out. Right. Then, okay, I think enough time now. Right now, encapsulation, we'll go to the theories. Right now, okay, you know what do you mean by encapsulation? Encapsulation means you hide these instance variables from the outside misuse. Because now here, if you do not have the private field enabled here, then everyone could access, even if it's declared as public, let's say, right now, then everyone could access with the dot operator, object name dot, and then they can change the values. They could change the values using the dot operator. But since you have made it as private, then no one would be able to access these instance variables through using the object name dot operator. Therefore, now no one will be able to access these instance variables. And then, if you want to allow them to change, then you have to generate the set methods. And if you want to read the value as well, then you have to generate the get methods. Now, these you call as getters and setters or accessor methods. Therefore, now you can see that now encapsulation means the mechanism which binds together methods and the variables, right? And from the outside misuse or the interference. Therefore, encapsulation is achieved through making the fields in a class as private and providing the access to the fields via public methods. Now, making the fields, the instance variables as private and providing the access to these fields via public methods, public getters and setter methods. Public set method to set the value of that particular variable, public get method to read the value of that method, that field. Therefore, this is what we discuss now. Therefore, object contains instance variables. If they are visible to the outsiders, then out of the objects and any code that holds a reference to it can change the object's instance variable. Because using the dot operator, uh, it could change. It could access the values of the instance variables. Therefore, in order to avoid this, you make all the instance variables as private, and then you provide access to those instance variables using public methods. Right. Now, in order just to make sure the rules of the public, private, protected access modifiers. Public means public variables, methods, and classes. Scope is public, that means visible to all classes. If you have a class access, and if inside that particular class has public variables, methods, then all other classes which has access to the particular class visible can see all the public variables methods, right? If it is default variables and methods, if it is a default variables and methods, then default means package level access. Therefore, within the package, you can see any other class within the package can see the default variables and default methods if they have the access to the particular class. If it is private variables and private methods are visible only within the class. Therefore, even though you have access to the whatever the class with private fields, then no one will be, outsiders will not be able to see what are the variables and methods because only within the class they are visible. And if it is protected variables and protected methods, then visible to all classes within the package as well as through inheritance. Right. Therefore, this is a summary of last week what we did. Right now, you can see here. Now, this is what I said. If you have a class called bad OO and there's a variable called size and weight, and if you have another class called exploit bad OO, and then you can create an object of the bad OO class, bad OO. B is the object name. And then since size and weight are instance variables of the bad OO class, you have the public access to the size and weight. Then anyone, those who have access to the bad OO class, using the object name dot the variable name, object name dot size, they can change the value. The object name dot weight, b dot weight, they could change the value of the weight variable. Now this is legal, this is working, but this is error prone because anyone who has access to the particular class can change the values of the instance variables as required. Therefore, In order to avoid this, right now you're going to use the encapsulation. Encapsulation means because a good design should reflect maintainability, flexibility, and extensibility of the implementation. Therefore, design must include the encapsulation. How do you get the encapsulation enabled? Encapsulation is enabled by making all the instance variables as private. All the instance variables as private and creating public accessor methods to allow access to the particular fields. Like for an example, get method to read the value of the particular variable, set method to change the value of the particular variable. Right now, this is how you do it. The ways and means are keeping all the instance variables as private and making public access the methods. Now, how you do it? Now, for an example, you have class B and class A. Class A has access to class B. Therefore, class A could create class B object. And now class B has three instance variables, size, name, color, which are private. Then class A cannot access size, name, or color because object name is b.size, b.name, b.color is not working. Why? No access to these instance variables. Therefore, if you want to provide the access, you should generate public methods. So, public method get size, public method set size. Then, using the public method get size, you could read the value. Using a set size, you can change the value. Like for the name variable, if you want to allow to change, then you could say get method, get name, set name. For the color, get color, set color. Likewise, you can create. Now, this is how you make encapsulation. Right. Okay, then it's easier when you're using NetBeans. Right now, let's say, now in order to do this, you don't have to worry at all. If you just create, now if you're using NetBeans, okay, follow it with me now. Let's say now I'm going to delete all these codes right now. See, I just created the class student and I have three variables declared name, ID, and mark. If I want to generate the constructor, it's easy. What I have to do, right click, insert code, select the constructor, and select the fields you want to have in the constructor, click generate. Constructor generator. Right click, select insert code. You can see getter and setter. You can, if you want only getters, you can select getter. If you want only setter methods, you can select setters. If you want both generator, select getter and setter. Select all the fields which you want. All the instance variable will be listed here. And if you want to make these instance variables as private, enable this encapsulate. That would make instance variables as private. Now see, if you do not use encapsulate fields, these has not changed to private. But you can see public getters and setter methods has been changed for each instance variable. Right now, right click, insert code, getter and setter, select the fields, make it encapsulate and click generate. All these instance variables will become private and you can see the getters and setters will get generated. Now remember, if you don't want outsiders to set the values of the particular variable, then you don't have to declare the set method. If you don't want outsiders to read the value of the particular field, then you don't have to generate the getter method for that. Then if you require, then only you have to generate the getters and setters. Okay, quickly try out that. And then here from the test class now, if you want to set the name of the student object, you have to use the set method. If you want to change the set the ID value, you have to go on the set ID method. If you want to set the marks, set average mark 49.5. If you want to read the name, you have to go through the get name method. You have to read the ID, you have to go through the get ID method. If you want to read the marks, you have to go through the get average mark. Now, this is how you can assign the value. This is how you can read the value. Okay, quickly try out this. I will show you again what you have to do. It's very easy, right? You don't have to worry about this at all. Right now, you have to just declare the instance variables only. You have to just declare the instance variables only. Afterwards, right click, select insert code, select the constructor, select the fields, click generate. Right click, insert code, select getter and setter, select the fields and select encapsulate. Right now, if you want to generate individually, getters only, select getter. And if you want to read the value only for the name and the mark, you can only select these two. If you want to generate the getters for all these, you could assign these get methods, and then you can, if you want, you can encapsulate, you can select generate. Then you can see here, no one will be able to set the values, but they will be able to read the values. If you want to generate the setter methods as well, right click, insert code, setter, and you can select the fields. Right, anyway, it is encapsulated, you don't have to encapsulate again. Right now, anyway, the private field is done, you can select the set methods. Right now, this one would be okay. Right now, see, this is how you do getters and setters. Even if you want all to get all generated quickly, you can select, right click, insert code, getter and setter, select all, encapsulate, generate. This is how you do it then. Okay. Quickly try out. Then I'm going into polymorphism. Okay, 2 minutes for you to do this. Right. Then, right now, let's talk about polymorphism. Now, polymorphism is the capability of an action or method to do different things based on the object that it is acting upon. Right now, before I go into the polymorphism, let's see how can we do the inheritance. Right. Okay. Right. Now let's see how to become a subclass of a particular class. Right. Okay. Then. Mm, 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 mm. All right. Now we have already discussed this last time. Okay, I'll show you. Right now, here you can see there's a class called shape. There's a method called draw. Right. There's a method called draw, and class circle becomes a subclass of the shape class. Therefore, shape class get inherited the. Okay, let me do this quickly. Right. Let's add another class called shape. Right now, this for the shape class, there's a method I'm going to declare. Right now, I have a shape class, and then I have a circle class, let's say. Class circle. And circle class, I'm going to make a subclass of the, using the extends keyword, make a subclass of the shape class. Right now, that's it. Nobody, I'm going to have the square class. And I'm going to make the square class also a subclass of the shape class. Right now, this is a subclass of the shape class. Right now, I have shape class, which is the superclass, and the circle and the square are the subclasses of the shape class. Right now, in the test class, I'm gonna make a shape class object. Shape s equals new shape, and I'm gonna create a circle class object. Circle c equals new circle, and square sq equals new square class. Right now, I can call shape dot draw and circle dot draw and square class dot draw. Now, all these three methods are the shape dot draw, circle dot draw, square dot draw will display the superclass shape, that means the shape class draw method output that would say drawing a shape. Therefore, this is not what I want, right? Because the circle class, when I'm drawing, I need to say drawing a circle. Square class, I want to say drawing a square. Therefore, now what I'm going to do is, now I know since the shape class is the superclass, shape class had the method draw method, then the circle class is the subclass. Now I have inherited the draw method. Therefore, I'm gonna override the method. I'm gonna override the method. I'm gonna override the method draw. I'm gonna override the method draw. Right now, the superclass draw method would say drawing a shape. Now, this is not what I want to say. Now, I would say drawing a circle. Now, I have overwritten the draw method in the circle class. Therefore, when I create circle class dot draw, that would say drawing a circle. Now this is what you say. Different objects now, the square and the circle are the subclasses of the shape class. And now when I say the draw method, the command is the same, draw. The shape class says drawing a shape. And the circle class says drawing a circle. And the square class can say drawing a square. Drawing a square. Drawing a square. Right now, the polymorphism means different objects, different, respond differently for a same command. Now, same method draw each object. The circle object says drawing a circle. Square object says drawing a square. Shape object says drawing a shape. Therefore, the polymorphism means allowing different objects to respond to the same message in different ways. Allowing different objects to respond in the same message in different ways. Right. Right now, through overloading and overriding also, we could achieve the polymorphism. Right now, beforehand, quickly try out this. Right now, what I want you to do, create the shape class, and have method draw, and then create the circle class, make it as a subclass of the shape class, and then override the draw method. And create another class called square, make it a subclass by using the extends keyword, and then override the method draw. And then create objects from each class, and then execute the draw method. Quickly try out. Square class also the same. No? Thereafter, create the test class, create an object from each class, and then execute the draw method. Right. And then we have done this already. Overloading, overriding, we have discussed already. Right. Inheritance, we have discussed. Right. Okay. We have done this already. Right. Okay. Now, right, we have discussed this already. Right now, what I want to do is I want to talk about the Java Langlet object class. Right now, I'll give you 1 minute time. Quickly search what is the Java Langlet object. Java Langlet object. Quickly figure out. Right. What is the Java Langlet object class? Yes. Yes. Anyone tell me what is the Java Langlet object class? Yes, every Java class now, here we have been talking about Java classes, right? And then super classes, subclasses we have told. Right, then every Java class, if you create, now for an example, I'm going to create a class called item. Let's say I'm going to class call an item, create a class called item. And item class, I'm going to have int item ID and string item name, item ID, item name, and then integer quantity. Likewise, I'm going to have right now I have these fields item ID, item name, quantity, and the price. Right now, here this item class is a subclass of a particular class. What is that class? That is the Java Langlet object class. Right now, this item, I have just created an item class now. Now, this item class is a subclass of the Java Langlet object class. Therefore, every class you create is a subclass of Java Langlet object class. That is the object class, right? Class object is the root class in the class hierarchy. Every Java class has the object class as a superclass. Therefore, every Java class is a subclass of the object class. Therefore, in the object class, there are certain methods are declared. in the object class, because that is a superclass of every Java class, to in order to have the certain behavior of the Java class. Right now, for an example, right now this is the item class I have just created no, with some instance variables. Right now, let me create an item class object, item I equals new item. Right now, for the time being, the constructor has not been created there. No? Therefore, the default constructor is there. Now, if I print an object I, if I print the object I, now that would be displayed as class name and hexadecimal hash code. It would print it like class name. Class name is item. Inside the code package, code item and hexadecimal hash code. Right now, even if you create another item, right now, I1, again, that also would print a class name and hexadecimal hash code. Right now, you can see a different hash code. Right now, this is the default implementation, because in the object class has a method called toString, because that is superclass. No? Superclass has a method called toString. The toString is declared, the default implementation of the toString method is to print class name dot hexadecimal hash code. Right, and then also we have the, if you check now, the object class has a method called equals, right? Object class has a method called equals. Right now, let's see how the equals method works. Let's say this is I1 and this is I2, and you can check whether I1 dot equals I1 dot equals I2 likewise you can have. Right, now let's check whether the equals method, how it behaves. Now the default implementation of the equals method is, it will check whether the two objects are referring to. If the two reference objects are referring to the same object, that will return true. Now here, I1 dot equals I2, it says false. No? Now let's see what is the default implementation. I'm going to say item I3 is equals to I1. I'm going to say item I3 is equals to I1, and I'm going to check I3 dot equals I1 dot equals I3. All right, now whether I1 and I2 are the same, I1 and I3 are the same, that's what I'm doing. Now, the default implementation of the equals method in the Java object class is to check whether two objects are referring to the same, it will return true. Therefore, now I1 and I3 are referring to the same object, it returns true. Likewise, in the Java object class, remember inside the Java object class, there are methods called clone. Now, this is the method which is inherited to every class, clone, and equals. You have clone method, equals method, and then we have clone, equals, and then we have get class. Now get class method will return the runtime class of the object, and then equals, and the hash code equals, and the hash code to string. Now that would print the string representation of an object. Now the default implementation of the toString method is to print a class name at hexadecimal hash code. And there's another method called finalize. Finalize is to call the garbage collector. Right now, that means when there are no more reference to the objects, we could call the finalize method. And then we have notify, notify all. Likewise, we have wait. Likewise, there are certain methods, right? Wait method is to, that means when you are working with the threads, wait method causes current thread to wait until another thread invokes. And notify method is to wake up a single thread which is waiting on the object's monitor. Likewise. Then remember, object class declared with clone equals hash code get class toString finalize notify wait likewise. Right. Now normally equals and hash code is goes together, and the hash code is used to now hash code method will return a hash code value to every object. Now it will return a hash code to an every object. A hash code method will generate a hash code to an every object. Then using equals method, you could check whether two objects are referring to the, that means whether two objects are the same. That means if two object dot equals returning true, that means the hash code also the same. Right, then the hash code is the same. Right. Then we have to talk about this. Right. Therefore, now quickly if you go through, the Java language object class is the superclass of any Java class you create, and this is extended by all other classes directly or indirectly. Every class you create is a subclass of the object class. Object class is not abstract, and it has defined some set of methods. It has defined some set of methods which apply to all non-primitives. That means it has permits generic code to handle all type of objects and common interfaces for all objects like toString, clone, equals, likewise. Then remember, the object class is a superclass in Java. Every class you create is a subclass of Java language object class. Right. And then it has some set of methods which has some standard definitions in order to work with all the objects in Java. Some certain methods are the get class. Now, as I said previously, get class is returning the running class object, and then the toString method is a string representation of an object. A default implementation is to print class name and the hexadecimal hash code. Equals method is to check whether the two objects are referring to the same. Hash code is to generate a hash code. A clone is to make a clone. Right. Right now, that is the certain methods available in Java. Right now, our clone method creates and returns a copy of the current object. Right now, here, okay, the equals method where I decide whether two objects are meaningfully equivalent. Finalize method called by garbage collector when the garbage collector sees the object can be referenced. Hash code returns a hash code. Notify method wake up the thread. And notify all wait method cause the current thread to wait until another thread calls. Notify toString method returns a text representation of the object. Right. Now that is, those are the methods available in a Java language object class. Right. Now the get class method is returning a class object. Now the get class object is returning a get class object is returning a class object. Get class object is returning the running objects class, right? Therefore, it is returning a class type object. Every type has a single class object that represents its runtime class. Right now, contains type information such as methods, fields, class name, super class, likewise. Right. Okay, then you can check whether you can get the class using the get class method as well. Right now here, even if you want to get the class object, get class. Now you can see right now if you say the class C, then you can see you can get the uh, I1 dot get class, and then let's say C I2 dot get class. I3 dot get class, right? Then if you want, you can check whether these are the same. C equals D, or C equals E. Now, when I say I1 and I2 and I3 are returning the same class object, now get class method is returning the running object class. Therefore, item I1, I2, I3 are the same class objects. Therefore, that is returning the same. Right now, let me create another class called student. And here, let's say I'm going to create another object called student S1 equals new student, and the class EDE is S1 dot get class, and I'm going to check whether C equals D and C equals E. Right now, you can see here this should give me C equals D true and C equals E false. Why? E is a different object, different class, student class. Therefore, you can say C and D are referring to the item class. E is referring to the student class. Now, if you just print E, what it would print? You can say class code dot student, and if you just print C, if you just print C, that would print class code dot item. Right now, you can see this is how the get class method works. Get class method is returning the class of the current object. Right. Now that is how the get class method works. And thereafter, the toString method. The toString method is the default implementation of the toString is the default implementation of the class. String representation as default text implementation or the string implementation of the object. Right now, here, let's say student has only name. I'm gonna have right, and then item has these fields. Right now, in the test class here, right now I'm gonna have I1 is an item class, and then now the get class is done. Right. Right now, if you print I1 object, that is the item class, and S1 is the student class. Right now you can see these are the default implementation of the toString method is to print the class name and the hexadecimal hash code. See, class name and the hexadecimal hash code. Even if you have another object from the item class, it will give you different hash code, right? Hexadecimal hash code. Right, I2. It will give you a different hexadecimal hash code, right? Now, this is how it's gonna give you. But now this is what the default implementation of the toString method. If this is not the what you want, if this is not what you want, then you can have your own implementation. Right. Therefore, we're gonna override the toString method, which is overridden by the toString, which is over now. Sorry, the toString method is inherited from the Java Lang object class. That means in the superclass it is declared. Therefore, I'm going to override the toString method. Now I know that the toString method, the return type is a string value. Therefore, public string, and the method name is toString. Right now, either you can type like this, and then now we have to return a string value. No? Then we can say return item object. If you want to display return. If you say item class, that's it. Right now, you have overridden the toString method just saying item class. In the student class also, if you have if you say student class, right now you have override the toString method just to represent the class name. Right now, here when you print I1, I2, and S1, it would print item class, student class. Because you have changed the default or the default implementation of the toString method, because Java Lang.object class has declared the toString method to display the class name and the hexadecimal hash code. But now we have overridden the toString method in the item class just to say item class. Right now, this is how you can change the behavior. Right, if you want to display, let's say, item ID and the item name. If you want to display the item ID and the item name, then it's easy. You can say item ID plus item ID plus item name. Right. Likewise, you can have the toString method the way you want. Right now, just let's leave the student class for a while, and then here, if you print the item class objects now here it would print item ID and the item name. But now currently we have not assigned any value for the instance variables. All these are instance variables with no values. Therefore, the constructor will assign the default values. Therefore, default value would say integer as 0, string as a null. Right. Here I'm going to generate the constructor as well in order to get some values here. Therefore, insert code constructor, select all. Right. Done. Now you can see here, if you want to declare the item class, you need object, you need to pass the values. What are the values you have to pass? Item ID, let's say 101, table, quantity 10, and price is 1500.99. Right. Right. Now let's say I have the same set of values. I1 and I2 are the same values, right? And then if I print I1 and I2 objects, now I1 and I2 objects will display the same because this is what I have the values now. Right now I1 and I2 values will display the same. Right now if I check I1 and I2 are the same. Right now if I check whether I1 and I2 is the same, then I1 dot equals I1 dot equals I2. Still that would return false because I1 and I2 are two objects are referring to two different variables are referring to two different objects. Therefore, it will return false. Right. Therefore, now there even though you have the same values, it won't give you the two objects are not the same because two different objects. Right now, you can have some set of values, table, chair, 25 chairs, and 150. Right now, if you print it now, I1 would print item ID and item name as table. Item I2 would print item ID as 102 and chair. Two objects are not the same. Right. Because now this is how right now this is currently we know. Right. Okay, quickly try out this and then thereafter we'll try the equals method, how to override the equals method as well. Right. Then right now we know how to change the string representation of our object class by implementing the toString or by overriding the toString method in a particular class. Right. Okay. Right now, even if you are using a NetBeans IDE right now or any other IDEs, right, you don't have to type this. What you have to do is right now without the toString representation, right? That means if you have not implemented override the toString, now the default implementation would be the class name and the hexadecimal hash code, right? Now it would print class name and the hexadecimal hash code. If you override the toString method in the item class, right now you can do that by right clicking, insert code to string. Right click, insert code to string. Then you could have the default implementation. You have changed the default implementation of the toString method by overriding the toString method in the item class. Right now, here this would display now according to the way we have written inside the item class. Now that would be right now it should display item bracket, item ID, item name, quantity likewise, because this is the way you have implemented it. Right now, this is the way it should display now. Therefore, you can change it according. If you don't want the brackets, you can remove it. No worries. You can have the way you want, and then you could display. If you want to display only relevant fields, that also you could do it. Right. Now, if you have implemented the toString method, then when you print an object of that particular class, that would display according to the toString method. Right. Okay. Now we are done with that. Right now, the equals method. Right now, a equals method also. Now, the default implementation of the equals method is to check whether the two objects refer to the same. Right now, if you want to change it, then I'm gonna have the equals method as well. I'm gonna right now equals method returns a boolean value that we already know. Therefore, boolean equals, and it accepts. It has a parameter, object type parameter, because it compare objects. Let's say object obj. Right now, it has returned true or false. Right now, here what I'm gonna do is if the object whatever the object here we have is an instance of, if it is a type of item, if it is an instance of an item class object, then only I could work with that. No, if it is an instance of item class, then if it is an instance of an item, I'm gonna check whether let's say now you can have your own semantic now. Right now, what I want to do is right now I want to check whether it is both objects have the same item ID. Right. Let's say now I'm gonna create item object called item equals. I'm gonna pass this object into item because this is an item type object. No, right now I'm gonna get it, and then I'm gonna check if item ID is equals to item dot item ID. If it is the same item ID, then I'm gonna return. I'm gonna return. I'm gonna return true. Otherwise, I'm gonna return false. All right. Now, if I have two objects with the same item ID, now I have changed the behavior. If I have the two objects with the same item ID, will return true. Now, if I check I1 is equals to I2. Right now, I1 dot equals I2. I1 and I2 has different objects, different item IDs. Therefore, now this would say I1 and I2, I1 dot equals I2 as false. Right. Therefore, now what I'm going to do is I'm going to change item 2 item ID also into 101. Even though two different objects, but now The equals method is checking whether two objects has the same item ID. Because now same item ID, yes, it is true, therefore that returns true. Therefore now this is how you change the behavior of the equals method. The default behavior is to check whether two objects refer to the same. Now we have overriding by changing it, by overriding it to check whether the two objects are having the same item ID value. If it is the same item ID, I'm going to return true. Now this is how we use the equals method. Right now, commonly we use the toString equals these things. That's why I have showed you this. Right now, you could try out. Now get class also I showed you. You could search for hash code, clone, verify, notify, wait, like those things you could try out. Okay, quickly try out the equals method as well. Now here I have changed the semantic in order to check whether the two item objects are the same. You can try out quickly. Then, okay, that is how you do the equals method. Right, then toString equals, right, then object equals method. Right, that's what you have done. Here's the default implementation of the equals method is to check whether both are referring to the same. Right, and then right, then equals method use only the equals operator for comparisons unless you override equals. Two objects are considered equal only if the two references refer to the same object. That's what we did. We have changed it. And let me show you the hash code as well. Hash code is typically used to increase the performance of a large collection of data. Collections would be hash map, hash it, hash code values of an object determine how the object should be stored in a collection. For an example, right now, here you can say you have to store four objects, Alex, Bob, Dick, and Fred. Right now, then, here if you want to store these values based on the hash code and based on the alphabetical order, you're going to generate a code. And then let's say Alex has 42, Bob has 19, Dirk has 42, Fred has 33. Likewise, then values with the same hash code you're going to put into a same storage. Right, therefore, now you can say same 42 bucket contains both Alex object and the Dirk object. Therefore, now using the hash code, you could generate the hash code method. You can have a hash code value, and based on the hash code value, you can find out where to store it in a collection, the right bucket. Therefore, using hashtag right now, using the right bucket, you can find using hash code. Like now, for an example, now inside this bucket, let's say 42 bucket, you have two objects, Alexander, and then using the equals method, now you could figure out by comparing each and every object whether it equals to Alex or you can check and you could find out. Therefore, find the right bucket using the hash code, search the bucket for the right element using the equals method. Right now, that is how the equals method and hash code goes together. Right now, if the two objects are equals, their hash code should be equal as well. If the two objects are the same, their hash code should be the same. Right. Therefore, as a summary, right, this thing in summarized form, you can see if x equals y equals true, that means hash code also the same. If x and y's hash code is the same, then it's not required to say x and y are equals. If x equals y false, then their hash codes might be different. Not a requirement. If x is not equals to y hash code, if x hash code and y hash code is not equals, that means x and y are not equals. X and y are not equals. Right? Remember this. Right. Now, I'm going to go into the collections framework. Now, Java has a framework called collection. A collection framework is a set of you can say unified architecture for representing and manipulating collections it has. It has interfaces and implementations, algorithms, likewise. Then under the collection framework, it has, you can say, a list, set, queue, likewise we have. Inside the set, you have hash set, and then inside the queue, we have a linked list, priority queues, and then you have the maps. Inside the maps, you have a hash map, hash table, likewise. And here we're going to talk about in this one, list. In the collection interface, we have list. Inside the list, you can have array list. And right now in the collection framework, we have object. Object contains arrays and collections. Right. Now, the collection framework, what are the operations we could do? Now, the basic operations are add objects to a collection, remove object from a collection, and find out whether the object is available in the collection. And if it is available, retrieve the object and display or iterate through the objects in the collection are the basic operations in the collections framework. Right. Now, I said that collection framework has set, list, queue, map. These are the four flavors in collection framework. Right now, therefore, collection framework has map, set, list, queues. right? Under maps, we have hash map, hash table, tree map, linked hash map, like sets, we have hash set, linked hash set, tree set. Under list, we have array list, vector, linked list. Queues, we have priority queues. And utilities, we have collections and arrays. Arrays also a utilities in collection framework. Right now, collection has four basic flavors: list, set, map, queues. Right now, I'm going to talk about list. List means list of things. List of things. Right. And list interface has a list of things. A collection, that means previously a variable could store only a relevant type of objects, right? One value at a time. If it is an array we discuss, array could, when you are declaring an array, the array value should be predefined. And then you can have only up to that number of items only, because it is predefined size. Collections are dynamic. Right now, list interface is working with index like arrays. Then the list can have, right now, it's dynamic. That means you don't have to have size defined. That means the list can be grow dynamically. Then a list has some set of methods with related to the index. Therefore, list is working with index. Then the list implementations are array list, vectors, and linked list. Then under that, we will be working with the array list and set interface. Set interface is cares about the uniqueness. Therefore, there will be no duplicates in the set interface. Right now, the map interface, right, about the unique identifiers. Then with this, using a unique key, you can work with the map interface. You can have keys and the values in the map interface. And the queue interface also, we have queue interface works with the first in, first out manner. And then in computers also it uses priority queues, right? Then the jobs are scheduled using in the priority queue manner, right? And then under the collections framework, first I'm going to talk about the array list. The array list. Array list is a type of is a list. Array list is a list. Because array list and arrays, the main difference is array list can grow dynamically. Then you don't have to declare the size. But arrays, you have to declare the size. Array list can grow dynamically. And array list is efficient in insertion and searching an element from an array list. Right, now let's see how to declare an array list and then how to work with the arrays. Right, now what I'm going to do here is, now here, this is, I'm going to leave this item class for a while. And inside the test class, what I'm going to do is here, I'm going to remove this. I'm going to create an array list. Let's say, now in order to create an array list, you could use array list. You can call the array list. Now array list is from java.util collection. Java.util array list. Now array list, then you can have the generic what you want to have. Right now, let's say I'm gonna have, okay, right, nothing. Let's say numbers equals new array list. Right. Now here, now since if I want to store the numbers into that means numbers as the array list, then I can declare the type as integer. Right, now array list. So right, then you can have numbers dot, I can add integer objects. Let's say 10. Let's say I have integer x equals 5. I can say numbers dot add x. Likewise, I could add. and then numbers dot add. Right now, I can display the numbers dot get 0th index. I can get it by 0th index and first index and the second index and numbers dot size. Right. Likewise, I can do it. Right. Now you can see here, right? If I have not implemented this integer as a generic, right now what's gonna happen? Now you can see here. Now here right, you can see it says size is 3, 10, 5, 20, 10, 5, and 20. Now now you can see here, right now I have created an array list of um, call numbers and I have added some numbers. Right now, this is how I work with this. Right now, what is the type of objects right now? Here, can I have, let's say, a string variable, string y equals 15, and then can I add numbers dot add y? Right now, here you can see here I have an integer value. Here I have an string value, which is 15, right? And then using easily rather going through this, you could use an enhanced for loop for now what type of objects available in the numbers right now. Let's say for integers, for indexing numbers. Does it say variable already defined? Right. Now I'm gonna print I. Now when I try to do this, now you will see I'm getting an error saying here the array list, the generic type I have not declared. Now here, therefore this is not integers, right? Let's say now if it is object type, and now if it is an object type, now I could say it is object type values available in the numbers collection. Now these are object type. Now here this is the object type. And therefore, if you don't want to declare such object type array list, if you want to declare only integers, then you need to say this is an integer type. This is an integer type. Right. Then you can say you cannot add y because y is a string value. No? Therefore, you cannot add y. Now, here you can see here these you can go ahead with integer type objects right now. Now, this numbers array list is a type of integer. The numbers array list is a type of integer. Right now, this is how you could define an array list. This is how you could define an array list. This is how you could add items to an array list. This is how you could get the size of an array list. This is how you could iterate through the array list using uh, enhanced for loop. If you want, you could go ahead with the normal for loop as well if you don't know the size. Therefore, you can say numbers dot size. And then you could display like numbers dot get the index number. Right. Likewise, you could display the values using the by index by index. Now, this is how you declare an array list. This is how you declare an array list. Right. This is how you display an array list with numbers. Right now, right. Thereafter, if you want to declare a string arrays, right now declare an array list called names with the type of string, and then add some names, and then run it and see how it can go. New integer 55. What does it say? You can say you can add the new integer objects as well, because this is the integer type and array. In type is integer. But I'll give you a few minutes for you to try this one, and thereafter next thing is we're going to create array list of item type objects. Array list of item type objects. Now this is an array list of numbers. Then afterwards, if you want to sort this, even it is so can be sorted quickly. Numbers dot sort or connections dot sort. And after this, I'm going to use this for loop to print the values. Then it will display the sorted list like this, right? You quickly try out this and then try to have some numbers, sorry, names, with some string values, and then see whether how the sort method works. And thereafter, let's see how to create integers and see how to create a list of items and see how it can be sorted. Right. Then let's try to create now. If you have created a string class, let's say, if it is string names, let's say Jane, Nora, Bill, and right. But now, if you print this, now you can see we have created an array list with the type of string, the generic is string I have used, and then here the sorted list will print in ascending order. Right now, this is how you work with the right now the defined data types. Like you have primitive data types, then we have you can sort. But if I want to create an item type objects, right now item type objects called item list. Right now, here if I create an item type objects, if I create an item type objects, right now item list. Right now, let's add some items to the right now item list. Right now, we need to add the items list. Right now, you can see here there's a problem here. Let's add some items to the item list. Right, item list. Okay, if you have created an item list objects, item class objects, item I equals new item, then you have to pass item ID 101, item name table, the quantity which is 10 and the price, let's say 15.5. Right. Likewise, if I have now you can say item list dot add I object you could add it. Right. Or else you could add item list dot add. You can say new item. Then you have to pass the item values here. Let's say 105 share quantity 20 1500 and this is 750 and you can have another set of values 102 104 103 table chair desk bed tool Right now I have added some items, and then right now variable type, item type, objects available in the item list. Here I'm gonna print it. Right. Right now, when I do this, you will see right now this is how you can okay, this for loop. Now you know how to print the item index now. Then no need of this. Right now, if you run this, now you can see here we can create an item objects from the item class added into an item list. Right now, there is no order 101, 105, 102, 104, 103. Likewise, you can have it. Right. Now, if you want to sort this, now, if you want to sort this, if you try to use collections.sort, if you try to use collections.sort and then if you thereafter if you try to sort it and then if you try to print it, now you can see you will not be able to do this. You will get an error saying no suitable method found because there is no way to sort this because this is custom created class. Therefore, in order to get this thing done, we have to go with the um, we have to go with some other implementations. Right now, in order to do this, we have to work with the comparable interface. There are two interfaces which I'm going to do today, comparable interface and the compare to interface. The comparable interface is used by the collections.sort method and the Java utils.arrays.sorts method to sort list an array of objects. To implement a comparable interface, a class must implement a single method called compare to. And the compare to method has three variations. That means when you compare two objects, you either one is larger, one is smaller, both are the same. Those are the three cases, no? Therefore, when you compare three objects, we could check whether greater than, less than, or equals. Therefore, now what I'm gonna now these are the three cases: greater than, less than, or equals. If it is one, this object is less than the another object, it can return a negative value. If this object same to the other object, it can return 0. If this object is greater than the other object, it can return a positive value. Therefore, it will return an integer value. Right now, let's see how to have this comparable interface added. Therefore, we have to add this into we have to implement the comparable interface in the item class. In order to implement this in the class item, you need to say implements comparable. Right now, when you take the comparable, it says the interface imposes a total ordering on the objects of each class that implements it. This will become the class natural ordering. And the class compare to method will be referred as the natural comparison method. Right now, this would right now there are three cases: greater than, equal, or less than. If it is less than, negative value, equals 0, greater than, positive value, it has to be written. Right now, the type of objects I'm going to compare is item type objects. Right now, when I implement the comparable interface, here it will show you that error saying the compare to method is missing. Therefore, we have to override the compare to method. Therefore, I click insert code, implement method compare to. Now we have to implement the method compare to. Now compare to method will become the class natural sorting order. Right now, this is where we have to have our own semantic right now in order to how you need to compare the objects. Right now, let's say, now I want to compare objects by the item ID. Then I can check whether I can write like this. If item ID, if item ID is less than, if item ID is less than object dot item ID, then I could say return -1. Else if I would say if item ID is same as if item ID is the same. If item ID equals to 0.item ID, I'm going to say return 0. And else, that means if item ID is greater than the ordered item ID, then I'm going to say return positive value, a plus 1. Right, now I could do it like this. Right, now when I compare, now this is what I have done. Now when I compare collections.sort, you can see that now the class item has a sorting method, which is the compare to method. Therefore, now that it has become the class natural or the default sorting order method. Right now, here if you run this now, you can see the items get sorted in ascending order. Ascending order 101, 102, 103, 104, 105. Ascending order. Right now, this is because of we have done it in this manner. If you want to do it in the descending order, you have to just change. If it is less than positive value, if it is greater than -1. If you do this return values changes, then this would be sorting in descending order. Now the values will get sorted in descending order by item ID, according to the item ID. Not only the item ID, you could check with the price even. If you want to go ahead with the price, then right, because you can compare with the price. Right now, this would be descending order by price. Now items would be sorted in descending order by price. Now the items would be sorted in descending order by price. This is how it goes. Even if you want, you can sort it by the ascending order. Ascending order means you have to change this one. Right now, this would be sorting in price ascending order, by price ascending, because that is the class natural sorting order. Right. Therefore, rather writing this type of values, rather writing this. Okay. If it is, let's say, item ID, if you want to do it now for this instance. Okay. If it is for the price, since it is a float value, I will show you how to do that later on. Just for the time being, let me have it as item ID. Right. Now, rather writing the whole process, you could have you have returned a positive value, negative value was 0. Return item ID minus ordered item ID. Right now, if it is item ID is greater than this, it would return a positive value. If item ID is less than the or object item ID, it will return a negative value. Both are the same, it will return 0. Now, this line will do the trick of all these lines. Right now, if you do it now again, this will get sorted by item ID in ascending order. Item ID in ascending order. See, item ID in ascending order. If you want to do the reverse, in order to do it in descending order, you have to just do it ordered item ID minus item ID. Right now, this would sort in. Now, previously it is in item ID ascending. Now, this would be item ID descending order. Item ID descending order. See, item ID descending order. Now, if you want to do it by the price, now price is a float value. Therefore, this has to return an integer value. No? Therefore, if you want to return, that means if you want to do it with the price by descending order, let's say price, then we need to return an integer value. We need to return an integer value, and then we need to return ordered price minus price. Right now, then this would give you a float value, and then finally you convert into an integer because it doesn't matter now, because we are considering the sign on positive, negative, 0. Therefore, now it will get sorted in descending order by price. Descending order by price. This is how you do it, the compare to method. Right now, either let me have this again, one more line. This is for the item ID minus order. Item ID is the, for your reference, this is ascending and this is descending by ID. This is descending by price. Right now, okay, quickly try out this, implement this comparable interface. And then first you need to implement the comparable interface at the beginning, right? Now, when you implement the comparable interface, you will see that here, this will add comparable item, right? Implements comparable interface. You have to do that first, and then only you have to write the compare to. You have to override the compare to method, right? In order to get this, either you can right click insert code, you can click on implement method, otherwise you can just write public in compare. And this is how you get the compare to method, or how you implement the comparable interface. All right. Let's say now I want to display. Right now, I'm gonna show you again. Let's say I want to have another class to come to sort items. Then how can I do it? Okay, let's do it quickly. I'll give you 1 minute for you to try this quickly and then tell me. Okay, the other thing is right now, let's say I want to have another class. Now, don't make it confusing, right? If you feel like confusing, just make sure these two are two different things, right? Now, I'm gonna create a class. Okay, in order to make this, I'm gonna write it as sort by. Sort by price, yes, price. Now I have already implemented a natural sorting method of the item class to sort by item, right? Item ID in ascending order. Now I have, let's say, to sort items by price, I'm going to do. Now to do this, previously we have implemented comparable interface. Remember comparable interface, not this time. We're going to implement comparator. Comparator is a comparison function which imposes total ordering on some collection of objects. If you are using comparator, you must implement compare method. You must implement compare method. Then comparator, the type of objects I'm going to sort is item. Right now, as soon as you implement, it will give you an error saying compare method is missing. You can right click, insert code, implement method. You can select compare, or you can just write the compare method. You can just write the compare method. Compare method will return an integer value. You can write public int compare, and you need to pass two values to be passed. And let's say now here what are the two values you want to pass, right, in compare method right now, whether it is an integer value or whether it is an object or likewise. Then we need to pass object values, object x and object y. Right now here you will see that is not the object, you have to compare the item values. Right now compare method with items. Right now here you can again check, you need to compare with the price, you have to do it. Now we have to return integer value, we have written, therefore we could say int as I showed you previously. Now I want to sort it by price. Now then in descending order, let's say then y dot, now y dot price minus x dot price, right? Y dot price minus x dot price. Now this is how you sort by descending order according to the price. Now sorted by ID, yeah, sorted list by ID. Right now, if you want to do the same thing, sorted by price, now we need to say collections dot sort item list. And now we have to say new sort by price. Right now we need to sort by the price. Therefore, we need to pass here when you call the collection the sort method, the class you want to sort. Now it will be sorting by the price. Now it will be sorting by the price. Sort by price. Now here you can see the first one would be ID sending, here price descending. This is how we do it. Right now, this is what we did. We have used sort by price, sort by price. My goodness. Okay, let's rename it. Refactor, rename. Sort by price. Okay, no worries. Right. Okay, then this is how we do it. Right now, if it is an integer value, you don't have to do it like this. Right now, again, if you have implemented the getters and setters, if you have implemented encapsulation here, if you have implemented encapsulation here, you will not be able to access by the item object dot named. Therefore, here, let's try that as well. If you implement the getters and setters, we need only the getters, no? Then I'm gonna set getter. I'm gonna select all and encapsulate and generate. But then these will become private, and there will be get methods generated for all the fields. But I want only for the price, no? Then I will make sure all the other things are removed. If I have generated getters, then here you have to access to the get price. This is how you work with the price. Now what I want you to do is write another method called sort by quantity, and then sort in ascending order using comparator interface. Do it quickly to sort the items by quantity in ascending order. In ascending order. Okay, or descending order, it doesn't matter, it's up to you. I'll give you 1 minute for that. Sort the items by quantity. All right, now I do that. You can right click, insert Java class, but I want to have sort by quantity. Sort by quantity, what we have to do, we need to implement the comparator interface, and the type of objects are the item type. Now we need to right click, insert code, implement method, compare to. Right now, let's say by ascending order, right? Then return one dot. Now the problem is we will not be able to access the quantity now, because in the item class we have removed the get quantity method. Therefore, let's quickly get the quantity method as well. Get quantity. Otherwise, we will not be able to access them. O1 dot get quantity minus O2 dot get quantity right now, because these are integer values, therefore it will return an integer value. This would be in ascending order, right? Now this is what we have to do, and then it's matter of right now we can say sorted list by quantity. Therefore we have to say sort by quantity. Right now, if you sort it now, it would be sorting by quantity in ascending order. Right now, let's see. Sort by quantity here, sort by quantity 10, 12, 15, 20, 200. Now, this is how it gets sorted according to the ascending order by the quantity. Now, this is how you do it. Right. This is how we do this. Okay, now the next day onwards, we'll be dealing with some practical sessions. Therefore, you better have NetBeans installed on your computer, and then I'll show you how to get the Java database server enabled. I'll do it in the morning and that day, and thereafter we'll be dealing with graphical user interface based applications. Most probably, we'll be dealing with one or two example projects, and thereafter we'll be giving you the project by next week, the assignment to be completed, and thereafter you have to start working on it. And then most probably by June second week, July second week, you will have to submit. Right. Thank you very much. Any questions you can ask now. Otherwise, we can wind up. Thank you.